Imagine you are sitting in a job interview. The interviewer asks, can you make a counter in Simulink without using the counter block? Or can you build a saturation block using only basic blocks? It sounds simple, but it's a real test of your thinking. These are called modeling based interview questions, and they are very common in Simulink interviews today. Modeling based interview questions check how well you understand the logic behind the blocks. They are not about using ready made blocks, but about creating them from scratch using simple ones. You may be asked to make a saturation block using min, max, and constant blocks, create a logical knot without using the knot block, design an up down counter using add, subtract, and unit delay. Sometimes you will also face questions on algebraic loops, subsystems, or simulation errors. For example, what causes an algebraic loop, or when should we use an atomic subsystem? These questions help the interviewer see how deeply you understand how Simulink models actually work. To answer these questions well, focus on the logic, like explain how signals move between blocks and why you choose each block, or practice small modules daily, like counters, limiters, or feedback loops, and always test your model to see if it behaves as expected. In this video, I will be implementing a few modeling based interview questions in Simulink step by step to help you understand the logic clearly and build your confidence for interviews. So, if you are preparing for a Simulink or model based interview, this video is for you. Let's start exploring how to think in blocks and model smartly, one question at a time. Let's begin. Let's start with first question, that is implement saturation block logic without using a saturation block. For this I need few constant blocks and one min and max block and one display block to view the result. So let's start implementing. First I will search constant blocks. So let's take this for upper limit and one more as input and one more for lower limit. Let's rename this upper limit. I will set upper limit as 100 and input. Okay, let me save this, and lower limit I will set as 50 and input let's keep 75 as of now. So let me explain you what is the purpose of saturation block. Basically, saturation block will set the limit of a signal value within the range. Suppose your input is 75, the upper limit is 100 and the lower limit is 50. Now the input value is 75 and it is within the range. So the output will be 75. Suppose if your input is 150, your input value is 150, then the output will be 100 because the upper limit is 100. It will take the upper limit value if it crosses the upper limit. And if your input is 20, so output will be 50 because it is crossing the lower limit. So to set the signal value within the limit, we will use saturation block. Let's implement this, you will understand in better. Okay, now I need one min block. So I will connect the upper limit constant block to the min and input constant block to the min. Okay, now I need one max block. I will connect output of min to the max and lower limit constant block to the max value. Now I will take one display. Here we can view the result. So let me explain you. Okay, so now the upper limit is 100 and the input is 75. So it will calculate the min value. So min is 75. Yes, so the output will be 75. Okay, then here the max block, it will check which is the max value. So max value is again 75. Yes, so the output will be 75 because this is 50 and this is 75. The max value is 75. So output will be 75. Let's save this and run. Here you can see the output is 75. This is how you can implement the saturation block. Okay, we will also test this logic with actual block. I will take one saturation block and let's set the upper limit as 100 and lower limit as 50. Okay, let me take this input and connect it to saturation block, and let's copy this display. I will run it again. Here you can see the output is 75. Now let's change the input value. I will change this to 150. Now you see it is crossing the upper limit. So the min will take the minimum value. Right now the minimum value is 100. So output of min will be 100. Now come to the max block. Here it will take the max value. So the max is 100. So this will be 100. Output of max block will be again 100. Similarly, I will change the input of this to 150. So saturation block will set the input value within the limits. If it is crossing the upper limit, then it will take the upper limit as output. So let's run this. Here you can see the output is 100 and here also it is 100. Now let's change input to 20. Now let's see what it will happen. So the min block will take the minimum value. Right now the minimum value is 20. Okay, the output will be 20. Output of min block will be 20. Then let's come to max block. Here the max value, which is 50. Okay, that is 50. So here you can see the input is crossing the lower limit. Then the output will be the value of lower limit, that is 50. Okay, here also let's make this as 20 and let me run this. Here you can see the output is 50. So basically saturation block will set the input signal value within the limits, and this is how you can implement the saturation block logic without using a saturation block. Well, let's move to the next question. Second question, implement logical NOT without using a NOT block. Well, it's very simple, but again they want to test your logical thinking. So let's implement this without using NOT block. For this, I need two constant blocks. Let me search constant. Okay, one I will use for input and one is just to make the logic work. You can think as this way. And one I need sum block. Let me double click and change the sign. I will keep plus and minus. And one I need a display block to view the result. So I will connect the input here and one more constant as input to the sum. There will be two constant block input for sum. So the logic is very simple. When input is 1, the output will be 0, and when input is 0, the output will be 1. Let's keep it 1 and let me run this. Here you can see when the input is 1, the output is 0, and when input will be 0, the output will be 1. So it is very simple. This is how you can implement a logical NOT without using a NOT block, by using just basic ones. Okay, let's move to the next question. Third question, create an up down counter without using a counter block. So let's implement this logic. For this, I need few constant block, two add block, one switch, unit delay, and display. Let's get started. I will explain the logic later. Let me implement this first. So I need total three constant block. One constant for controlling the control logic for increment and decrement operation, and two more for increment and decrement logic. Okay, this I will use for increment logic and this I will use for decrement logic. And I need add block, one for increment logic and one for decrement. and one switch to control the increment and decrement, I mean up and down counter operation. Then I need one unit delay block to store the previous value. Okay, let me rotate this. And then I need one display to view the result. Let's rename this constant as increment decrement control. Okay, by making this 1 and 0, I will control the increment or decrement operation. Okay, I will connect this to this switch block. When the increment or decrement control constant value is 1, it will perform the up counter, I mean increment operation. And when it is 0, it will perform the decrement operation, I mean down counter operation. Okay, let's connect this. And output of add block I will connect here, and this one I will connect here. So output of switch I will connect to unit delay, and output of unit delay I will connect to the both add block. Okay, the implementation part is done. This is how you can implement the up and down counter without using the counter block. We are not using any counter block. So let me save this and run. Right now you can see the output is 51. Better we will add this scope. Okay, and let me run this again. Here you can see it is performing up counter operation. It is starting from 0 and till 51 it is going, and the stop time is 10 second. We can later change the sample. Okay, let me make it 0. When this is 0, it will perform the decrement operation, I mean down counter operation. Now, okay, there is one issue. We have to change the sign. Okay, let's make it this plus and minus. Now it will work. Now you can see it is minus 51. It is down counter. Okay, let me explain you logic first. Then we will change the sample time as 1 second and view the result. So when this increment or decrement control is 1, here you can see this condition will be true because the input is more than 0. This condition will be true and output will be this one. So here what it is happening, one constant block is there with value as 1 for first sample. Okay, first sample the unit delay initial value is 0. Okay, so the output will be 1. Okay, let's keep this one. Okay, sorry. Here, okay, for first sample, the unit delay value is 0 and this is 1. 0 plus 1, it will be 1. And then the output will be here 1. Here the output will be 1. And then it will go to unit delay. Okay, then let's go to next sample. For second sample, what will happen? Here the one input is this for add block, from constant it is 1, and 1 from unit delay, because unit delay will store the previous value. Okay, 1 plus 1 it will be 2. Again for second sample, here the output will be 2. Then unit delay will store the output as this output 2 it will store. Okay, for third sample, here the input will be 2 and this is 1. Then the output is 3. And then here also the output will be 3. then unit delay will store 3. So till for stop time is 10, it's keep on moving. Okay, it's keep on going, then the final result will be 51. So similarly, in case of decrement, when this is 0, okay, this condition will be true, so output will be this. Okay, the switch output will be this one. Let's take this. Let me delete these things. Okay, here what will happen, so it is 0. The initially the unit delay is 0. Okay, initially the unit delay is 0 for first sample. Here what it will be, output will be -1, right? 0 minus 1 is -1, -1. Again here the output will be -1, and unit delay will store the -1, and for next sample here it will be -1. Okay, -1 -1, it will be -2. This is how down counter will work. Okay, it's better to change the sample time. Okay, I will go to model settings. I will select fixed step, and I will keep the step size as 1 second. Now let's run this. Now you can see it is -11. If I open the scope, you can see for every 1 second it is decrementing, because just now we changed the step size and we have selected the solver as fixed step. And let's change this control to 1. Now it will do up counter operation. Here you can see the output is 11. For every 1 second it is incrementing. So this is how you can implement up and down counter without using a counter block. The logic is very simple. Just you need few constant block to add block, and one switch block to control the up and down counter, and then one display, and main is unit delay. Basically unit delay will store the previous value. Based on that we will do increment or decrement operation. I think it is clear for you. Let's move to the next question. Fourth question, implement multiplication without using a product block. It's very simple. You need one constant and one gain block and one display block. Let me search gain and then display. So if you want to multiply any value with some number, you can use gain block actually. So let me take as input 5. I want to multiply 5 with 8. So I will change gain value as 8. Okay. Then I will connect it with input. Now I will run. The output will be 40. This is how you can implement multiplication without using a product block. Basically, the gain will multiply the input value with the value which is mentioned in the gain. Okay, let's change this to 10. Now the output will be 50. So it's very simple. Let's move to the next question. Fifth question, create a square wave generator without using the signal generator block. Let's implement this logic. For this I need few basic blocks. Let me search one by one. First I will implement, then I will explain you the logic. First I need clock, then constant block, then I need mode block, then I need operator block, then one gain, and then scope to view the result. Okay, let me make connections and I will keep time as 10 seconds. Then I need to change this operator. Now I need to set a duty cycle. I will set duty cycle as 50% right now. Then I am using one gain. Basically I am using gain to set the amplitude of signal. Amplitude. Okay, I think implementation part is done. Let me save this and run. Here you can see I am able to create a square wave without using a signal generator block. So let me explain this logic to you. So here the time is 10 seconds. The output will be, let's connect this scope. The output will be like timer which goes from 0 to 10. Okay, and then comes this operator. When input is more than 5, then the output will be 1. So right now till 5 seconds, okay, till 5 seconds, here the output is less than 5, so output will be 0. Yeah, output will be 0 till 5 seconds. When here it goes more than 5, okay, then it will be like this condition will be true. Okay, the input is more than 5, then here the output will be 1. Then you can see it is 1. I can also change the amplitude. Let's keep it as 10 and let me save this and run it again. Here you can see the amplitude is 10. This is how you can implement square wave generator without using signal generator block. It's very simple. You need few constant block, one clock, and then operator, then one gain. It's optional. If you want to set amplitude, then you can use gain block and then one scope to view the result. So it's clear for you, I think. Let's move to the next question. Sixth question, implement absolute block logic without using the absolute block. Okay, let me implement this logic. Later I will explain you. For this again I need few constant block, then gain block, then operator, and then one switch I need, and one display to view the result. Okay, this constant block let me rename to signal check. When signal is, the purpose of absolute block is to change the sign. If the input is minus 50, the output will be 50. It will convert negative sign to positive. Okay, it will ignore this sign, actually negative sign. Okay, I will take one constant block as signal check, and this operator let's keep less than. When input is less than 0, I think let's keep it 33. Okay, when input is less than 0, I will flip that. Okay, I will multiply that value with minus 1 to make it positive. Okay, if input is like not less than 0, it means if the input is positive, then this condition will be false and the output of switch will be this, which is directly connected to the input. Okay, I think implementation part is done. Let me save this and run. Here you can see when input is minus 33, the output is plus 33. It's working. It's performing same operation as absolute block. When input is 50, the output will be 50. So let me explain you the logic behind this. Let's consider minus 33 as input. So when input is less than 0, okay, when input is less than 0, this condition will be true, okay, and this will be the output of switch block. Here I am using gain, okay, inside gain I am the value is I am adding the value as minus 1, okay, it will multiply the input signal with minus 1. So minus 33 into minus 1, it is 33. The output is 33. Okay, we can connect to display here. Okay, here you can see after multiplication it is 33. So the output is 33. Suppose when the input is positive plus 33. Okay, let me run this. Now still it is minus 33, but it is taking this as output because this condition it is false. This value 0 is you can see here 33 is less than 0, is it? No, that's why this will be false. This will be the output. That's why the output is 33. Okay, I think it is clear for you. Let's move to the next question. Question 7. Create a ramp signal without using the ramp block. Again, it's very simple. Let's implement. For this, I need one constant, one add block, one unit delay, and one scope. Let me save this. It's very simple. Here you can see there is a ramp in signal. If you want, you can change the sample time and you can do other settings also. So it's very simple, guys. If you want, I can explain you the output. Okay. For first sample, okay, let me take some number. For first sample, here it will be 1 and here it will be 0 and output will be 1. The initial condition of unit delay is 0. That's why for first sample it is 0. For next sample, it will store previous value, that is 1, and here it will be 1. 1 plus 1, it is 2. It's keep on going till the stop time, that is 10. You can further simplify it by changing some solver settings and all. So but this is the logic. If you want to create a ramp signal without using the ramp block, you can use this logic. Let's move to the next question. Eighth question. Implement XOR logic without using the XOR block. To implement this logic, you must know the truth table and the equation. Then it will be very easy for you to implement. Okay, let me implement. Again, I need two constant for this. Constant I will use for input A and B. Then I need two AND block. Okay, to perform AND operation, then to NOT block to perform NOT operation, then OR block to perform OR operation. It's very simple if you know the equation. So here you can see, first we will implement this part. Okay, not of B, not of B. Okay, then we will do AND operation, A and not of B. Okay, it is done. Then similarly we will complete this part, not of A, then B. Okay, this operation is also done and this is also done. Now we have to do OR operation between these two. Now let's connect to the display. Let me save this and run. Okay, right now the input is 1 1. You can refer this truth table. When input is 1 1, the output is 0. And when input is 0 0, when input is 0 0, the output is also 0. And when A is 0 and B is 1, the output is 1. And when A is 1 and when B is 0, the output is 1. When both are 1, the output is 0. Okay, this is how you can implement XOR logic without using the XOR block. You can use other blocks like AND, NOT, or OR block. Okay, I think it is clear for you. Let's move to the next question. Question 9. Implement rising edge and falling edge detection using basic blocks. This is little bit complicated. Let me implement first, then I will explain you. For this I need pulse generator and pulse type I will keep sample based. Okay. Then I need delay block and operator block and OR block. Then scope. Let me make connection first, then I will explain you. I have to change this operator. Okay, basically what I'm implementing is when there is a rising edge and falling edge, it will detect, okay, for one sample or two sample if there is a rising or falling edge. Let me save this and run. Okay, here you can see this is the input and here is the output. When there is a rising edge, it detected, and when there is a falling, okay, here it is falling, you can see again it is detecting. Again, when there is a rising edge, it is detecting. Again, when there is a falling, it is detecting. Similarly, it's go on. It's similarly going on till up to sample time, that is 100. Okay, let me explain you this. Okay, this is the input and this is the output. Here first, what it is happening, this is a greater and this is a smaller sign. When, okay, this the initial condition of this, it is 0. Okay, here it is 0, noted. And let me change this length. This delay length is basically this length. Okay, this length, I will change it to 1. Okay, okay, let me run this again. Now you can see the length has been reduced. Okay, let me explain you this. When it is 1, okay, when it is detecting the change, okay, rising edge. Okay, see, when this value is greater than 0, yes, it is greater than 0, initial condition is 0, then it will be true. And see, for just for initial condition, for initially it is 0 means it will be 0 for delay length of 1 second. For 1 second it will be 0. Only for 1 second this condition is true, that's why it is 1. That's why it is 1. Then after 1 second, the initial condition, okay, the initial condition will be same as this 1. Okay, then it will be false. Okay, this is rising edge detection. And similarly, in case of falling, okay, in case of falling, when the signal will fall suddenly here, when it is falling, okay, when it is falling, that time it will be like the falling is 0 and this one is, it is 0. Okay, but it will be 1 because after few samples it will be 1. So 1, this will be 1. One second, let me copy this number. Okay, for falling this will be 1 and this will be 0. Yeah, this 1 is, okay, this 0 is less than 1. This condition will be true during falling edge, and here this is related to rising edge. Okay, in rising edge, let me copy this. In during the rising edge, this was 1. Okay, this was 1 and this was 0. For initial condition it is 0. For 1 seconds it is 0. So this condition will be true because 1 is greater than 0, then the output is true. For 1, the it will be true till the delay length it is 1. That's why it is 1 here. Till 1 it is true. Then after delay length it will become 1. Okay, it will become 1 because this, it is having value as 1. So 1 is both are equal, then this condition will be false. Okay, that's why it is falling here again. This condition is becoming false, that's why it is falling. Again, there is a falling edge, this is the falling edge. Again it is detecting. For falling edge this will work, for rising edge this logic will work. Again, let's consider for falling edge. During falling edge, this was okay 1. Okay, and this is 0 during falling edge. You are getting my point? During falling edge, okay, okay. Sorry. During falling edge, the input is 0. This will be 0. Okay, and this will be holding previous value for delay length of 1 second. This will be holding previous value for delay length of 1 second, so it will be 1. So then here you can see 0 is less than 1. It is true. The output will be 1 for delay length of 1 seconds. Then after that delay length it will become 0. That's why during falling edge it is 1 for 1 second, then it is becoming 0. This is how it is working. I think it is clear for you. You just implement by yourself, then you try to analyze, then you will get the clear idea. This is how you can implement rising edge and falling edge detection using basic blocks. Okay, let's move to the next question. 10th question, implement an up counter. Once it reaches 20, hold the output at 20. After 10 seconds, hold for same period, then it must start counting down. It is little bit complicated, but try to read the question again and try to implement it by yourself and analyze it. Then you will get the better understanding. Okay, let's get started. I will search few constant block. Then I need clock, because here we are considering time after 10 seconds, so I need clock. Then I need fuse switch, then add block for increment and decrement operation. Then I need unit delay block to store the previous value. This is very important. Then one more condition is once it reaches 20, hold the output at 20. Then I need one more constant with value 20. Don't worry, I will explain you the logic later. Then I need one scope where we can view the result. Okay, okay, let me implement this. When it reaches 20, okay, hold the output at 20. Okay, this is fine. And this I need to change to -1 for down counting operation. And when it has to start down counting, when I think after 10 seconds, and hold for same period. So I need to connect clock here, and threshold is 10, and this is for up counter. Okay, this constant is for up counter and this is for down counter. And here is the add block. Okay, it will be like keep on adding or decrementing. And here is the unit delay. Then I think it's done. Okay, let me save this and run. Okay, it's working. See, first it is incrementing and then it is holding the value after uh, then after 10 second it is again holding for same period. I think after 10 second it is again holding for same period, then it is decrementing. So let me explain you the logic behind this. The question is implement an up counter. Okay, once it reaches 20, implement an up counter. This is the up counter. Once it reaches 20, hold the value. Okay, here I'm holding. Then after 10 seconds, here is the time. After 10 seconds, again I'm holding the value for same period. Then it starts counting down. Okay, let me explain this logic. First, here is the clock which will starts from 0. Okay, we can connect scope here and run. Clock will start from 0 till 20. It will go because the stop time is 20. Okay, when it is less than 10, okay, when it is less than 10, this condition will be uh, false. Okay, this will be true. Okay, this will be the output here. The output is 1. Okay, 1. Then here is the unit delay. It will keep on incrementing. Okay, unit delay initially it is 0. Okay, 0 plus 1, here it is 1. Then for next sample it will be holding 1. 1 plus 1 it will be 2. Again for next sample 2 plus 1 it will be 3. Again for next sample it is like 3 plus 1 it will be 4. Okay, keep on incrementing. So once it reaches 20, okay, once it reaches 20 till here, like for 5 6, it is like condition is false, this will be the output. Okay, once it reaches, it goes more than 20 here, then the constant 20 will be the output. That's why here there is a 20. Okay, then after 10 seconds, after 10 seconds again it is holding for same period, then it starts down counting. Here see, after 10 seconds, okay, this condition will be true because the number, it is, the value goes more than 10. Suppose it is 11, then this condition will be true. The output will be 1. Okay, minus 1. The output will be minus 1. This unit delay, it was holding 20. Okay, the value was 20. 20 minus 1, it is 19. It is keep on going again. Okay, 19, then it will be 18, then 17, 16, 15, 14, keep on down counting till stop time is 20. Okay, here you can see, this is how the logic will work. I think it is clear for you. Yeah. Okay, I think these are the top 10 questions, model based interview questions, and these are very common questions which are asked during interviews. Okay, thank you for watching this video, and if you have any doubts, any questions, you can ping me on WhatsApp, or you can comment below in the comment section. We will definitely help you out. Thanks for watching this video and have a great day.